And scientists, of course, use statistics. This includes the mathematical formulas. Some mathematical formulas to be careful of: averages and percentages. So you want to be sure about that. Also, pay attention to the data set at its center. It's a useful thing to know. So which formula do you think we can use to figure out what's at the center of a set of numbers? Let's put it this way. If you want to know how well you're doing in a class, you could use all of your test scores in that class to find the what? Well, if you're thinking, I think it's the average, yeah, and that's the most common measure at the center. But median might also appear. So be on the lookout for mean and average, same thing there, and the median. And to figure out the average, let me ask you this: what should you do? So let's say I have all of these test scores I mentioned before. What do I do with those test scores to find the average score? Well, think about that, and we're going to take this into the next slide, okay? So let's see that right now. So the average or the mean again, here it is. It's the sum of the terms divided by the number of terms. So just keep that in mind whenever you need to figure out the mean. It's this three-part formula. Average equals sum over number. Now, let's think about the median again. Think about that. Where in the list is the median? Is it the beginning, the middle, the end of the list? Well, we talked about it. It's the center. So this is the middle. The median is the middle term. But note what it's saying here. You can find that accurately when the data is arranged in order of least to greatest. So you want to make sure that the list of terms is in order first before you find the median. Another thing to keep in mind for median is you have two middle values. The average of those two data points will get you to the median. So let's do an example. Let's say there's a family, and the family has 3 children, right? In that case, the middle child is the child with the median age. But if the family has 4 children, then the average of the 2 middle children's ages is the median. So if you have an odd number of terms, the middle term is the median. Again, the list has to be in order. But if you have an even number of terms, that's when you find the average of the 2 middle values to get to the correct median. All right, now, please note that both mean and median are described on the GED Math Formulas and Symbols Guide. So they will be there for you if you forget them. However, we now need to switch to a different statistical term that's actually not on that guide. So let's start with an example. Let's say that there are 3 kinds of ice cream at a store. There's chocolate, there's vanilla, and there's strawberry. And there are 10 containers of chocolate. So let's say we have 10C. All right. There are 15 for vanilla. Have that. And there are 5 for strawberry. Okay. Well, since vanilla has the most containers, it represents what term when it comes to statistics? Think about that. What term goes along with what appears the most? Well, that is the mode. It's the value that appears most often. So, if we have a list that contains just basic numbers, let's say 1, 2, 2, and 3. That's in order. We can see it. What's this mode? It's 2, right? Now, some data sets, keep this in mind, don't have modes, while others may have more than one mode. So if the list contains 1, 2, 3, and 4, no mode. No term appears more than another term. But what about this list? Let's say I start my 1, 2, 2, 3 list and add another 3. What's the mode there? Well, in this case, it's 2 and 3. 2 appears twice, 3 appears twice, and they each appear more than the 1, 1. Okay? So in that case, 2 modes, 2 and 3 are the mode of the list 1, 2, 2, 3, and 3. Now, there's one more stat term to introduce. This also isn't on the formula guide, and that's range. So range, difference between largest and smallest. So what that means is it's largest minus smallest. Okay, so if I have my list from before, 1, 2, 2, 3, and 3, what's the range? Well, it would be the largest term, which is 3, minus the smallest term, which is 1, and that would mean the range is 2. So as you can see, range tells us how far apart the beginning and the end of a list are. Now, let's take a look at all of these terms together for one example set of numbers. So here it is. What you can do is pause the video. You can work through mode, median, range, and mean on your own. Then restart the video once you've done that, and we'll see the outcome. All right, so let's go through this step by step, bit by bit. Now first, remember, when you see a list of numbers, put it in order, and it's already in order as shown. Also, it can help to count the number of terms in the list. So how many numbers are in this list? Did you count it? Well, there are 15. So that way, if you lose track of a number, you'd know. So 15 numbers here. Okay. Now, let's go to the mode. Remember, that's what appears most frequently. This is going to be clearly shown when you put the list in order. Well, there are 3 ones, and that it means that 1 appears the most. Nothing else appears 3 times. So our mode is 1 and only 1. Now let's move to the median. Again, we have 15 numbers in this list, so that's an odd number of terms. So remember, when you have an odd number of terms, the middle term is the median. And in this case, since there are 15 numbers, the middle term will have 7 terms to its left and 7 terms to its right. So that makes 4 the median. 7 terms on its left, 7 terms on its right. Now for the range. Remember, that's largest minus smallest. We have the list in order. 9 minus 0 is 9. Lastly, mean. Remember, 3-part formula, sum of the terms over number of terms. So we add everything up, divide by that number again, which is 15. And the result of this in the numerator is 66. And 66 divided by 15, if you put that in your calculator, is 4.4. All right, great. Now, up next, we have 2 techniques whose formulas don't appear on the formula sheet. So let's be extra careful with them. So we're going into counting techniques. Now, the first of these techniques is combination. And here, this helps us pick a small group out of a big group, the number of ways to do so. But in this case, this is important for combination. Order does not matter. And the formula for combination looks like this. Okay, so let's break this up. R in the formula is the number in the small group that's being chosen out of n. And n is the number in the big group. So just keep that in mind. It's always R out of n. So that'll keep you on the right track. Beautiful. Now, again, since for combination order does not matter, here's how it could work. Let's say that you bought a box of chocolates. And you plan to eat 3 of the 20 chocolate pieces in the box. So 3 out of 20. Now, if you want to know how many different groups of 3 chocolate pieces you could choose out of the 20 total, that's where the combination would come in. Again, 3 out of 20, so R is 3, N is 20. And then you'd put that into the formula to find that out. And we will talk about what this formula means, how to use it in a moment. Now, for combination, again, order doesn't matter. So what do you think the other counting technique pertains to? Well, yes, it goes to when order does matter. So permutation, that's when order does matter. So it's like combination, similar parts, except again, order matters. So combination again, order doesn't matter. Permutation, order does matter. The formula for permutation is here. Note the difference in the formulas lies in the denominator. In the combination formula, you have this extra R factorial. That's what that exclamation point means. That R factorial is not present in the denominator for the permutation formula, but everything else is the same. Okay, now again, it's still R out of N. But let's think about the importance of order here. Let's do a new example. Let's say that you're going to throw a birthday party for your son or daughter, right? You went out, you bought 10 different balloons, and each balloon has a different color. So the question you'd like to answer is, how many different ways could you arrange 5 of those balloons out of the 10 total? So it's 5 different colors out of 10 different colors in that order. Now to figure that out, here's where the permutation formula comes in. R would be 5, N would be 10. Again, 5 out of 10, you just put it into that formula. All right, so remember, these formulas don't appear on the formula sheet, but there's a tool you can use to calculate them. And you might know what I'm talking about already. We mentioned it before. So here it is, the TI-30XS Multi-View Calculator. Yeah, we can use that. So you could skip the formula as long as you understand what we talked about with N and R are. So let's do a formal example here. You can pause the video and read through this, think about it, and then restart it, and we'll work through. Okay, so now, what's N, or the total number of students here? 6, right? And what's the R? That's the number of students who will be selected out of those 6. Well, that's 3. And what about order? Does order matter here? In other words, does it matter who Vlad chooses first or second or third? Well, no. So is this combination or permutation? Combination, that's when order does not matter. Again, N is 6, R is 3. We put it into the formula like so. So here's how you do that. All about this PRB button on the calculator. So to use the combination and permutation functions on the calculator, simply type the N number, type that in, press that PRB button, then use the arrow button to highlight 1:NPR for permutation, or 2:NCR for combination. After that, click Enter, then type the R number. After that, press Enter again for the solution. So if you need to go back through that, just go back in this video to get all of those steps, practice that so it's clear how to do that with the calculator on test day. Wow, okay. Now we're going to take a look at a tweak to this question to calculate an order, okay? Now keep in mind when it comes to the exclamation point as well, that factorial that I mentioned before. So let's say that we had 5 factorial. If you were to do this on your own, without the calculator, what it means is you start with that integer, that number 5. It could be 10, you would start with 10, whatever it is. And you multiply it by every integer down to 1. So when they give us the n factorial, the r factorial, that's what it means. put the number in for N and R, and if you are to expand this on your own, that's the way to do it. Okay, so let's continue with counting techniques in science. Now, most of the questions that are asking about order, you can think about logically, actually. So we mentioned the formulas you can use. We mentioned the calculator you can use. And now logic can be a part of this as well. And that's even when you could use the calculator. So let's look at a new example. Still about Vlad, but it's been tweaked here. So pause the video, read through this, get the lay of the land. When you're ready, restart it. Okay, now in this case, the order pertains to the positions that Vlad has to fill on the team. So how many positions need to be filled? That's the question. Well, it's 3. There are 3 positions: captain, co-captain, and 1 other member. Now again, sometimes we can calculate the answer to counting techniques questions logically. So let's see how this plays out. If we start with the captain position, how many of the students could be the captain? Well, any of the total of 6 students, right? We don't have any restrictions on that. So number of choices for the captain is 6. Now, if we move to the co-captain position, how many students are left to fill that position? 1 of the 6 students would be the captain. So how many remain? Well, it's 5 once that captain is selected. So 5 could be the co-captain. And now for the final position, how many students are left to fulfill that 1 other member position? Well, 1 went to captain, we had 5 left. Another goes to co-captain, so we have 4 left for that final position. And which operation do you think will pull the 6, 5, and 4 together? Should we add, subtract, multiply, or divide these 3 numbers? Now think about what we talked about just before with the factorial, with that exclamation point. The operation was multiplication. So 6 times 5 times 4, that would give us the answer based on this logical setup. And what is that product? Well, it's 120. Right, now we're almost finished with the different topics that GED data analysis and science questions test. But there's just one more formula to handle and a particular thing to keep in mind as we do that. So let's go to that final formula, which we think about all of the time right now. What is it? It's probability. Yeah. So probability is all about the chances. So that's what we want to focus on in particular. The chances that something will happen. So for example, whenever you look at or listen to a weather forecast, this is my favorite example. So we have weather. Keep in mind that weather goes along with probabilities. Knowing that there's a 50% chance of rain tomorrow is knowing the probability that it will rain tomorrow. Now, here's another example. Think about a game that people play that typically has a tiny probability of winning. Very, very small chance. And it typically comes with a big jackpot. Now, that game is the lottery, right? So the likelihood of winning the lottery is the same as the probability of winning the lottery. All right, so now that we've had those examples, there's a formula that we can use to calculate probability. Here it is. It's another 3-part formula. Number of desired possible outcomes over number of total possible outcomes. Now, this is not on the formula sheet, so just be sure of that and make sure that you have it. Another thing to know about probability is this. All different probabilities, when you add them up, you get 100%, or 1 if you're dealing with decimals. Another thing to note because of that, if you want the probability that something does not happen, then you take the probability that it does happen out of 1. Sometimes that's easier to do. So you have this formula as well. So let's test this out. Let's say you know the probability that it will rain tomorrow. You know what that is. If you know the probability that it will rain tomorrow, you also know the probability that it won't rain tomorrow. We just take the probability that it will rain out of 1 or 100% to get the probability that it won't. So if the probability that it will rain is 20%, the probability that it won't rain is 80%. Now, another thing to keep in mind is the probability that two independent events happen. What we do is multiply them together in this formula here. So probability of event A times probability of event B. So another example, right? Let's say that we wanted the probability that it will rain and be windy tomorrow. So if the probability that it will rain is 50%, and let's say the probability that it will be windy is the same, right? So it's 50% and 50%, or half and a half, because a half is a 50%. To put this together, the probability of both rain and wind, we'd multiply. And the outcome would be 1 times 1 is 1 over 2 times 2, which is 4. So 50% chance of rain, 50% chance of wind, together, the chance is 25% both wind and rain. Okay, so there we go. Remember, you can review any of these things on your own. Rewind the video, restart it. All of that's there so that you can master what's going on. Now, let's see how stats can play out on test day with the remaining practice questions in this lesson. Up first is a passage to introduce the data for the next 3 questions. Here it is. So pause the video and take a few moments to read through this and really focus on what matters here. Okay, so going through here, some things to pick up on. Metabolism is what this is all about. We got that. Then we get one example and another example. These are the kinds of words you want to focus on, the triggers for what matters. After that, it mentions rate, and even moving forward there, it talks about the varying of the rate. Okay, and then moving forward, right at the end, there's a comparison of animal species, okay, in regard to average metabolic rate and average body weight. So we know what's going on right over here in that graph. Okay, so now that we've talked through that, let's look at the questions. So first question for this information, here it is. Pause the video, take a few moments to read through this, restart the video, and we'll go to work. All right, so we're asked for the median body weight, yes, and the median would be where in this list of animals? Remember, the median is all about the center of the data, so it's in the middle here. And how many points? There's 7. So remember, when there's an odd number of terms, the middle term is the median. In this case, that's the 4th point. That would be in the middle. Now, we can count up to 4. Shrew is 1, cactus mouse is 2, flying squirrel is 3, 4 is the rabbit. And that's what you would put into the rectangle according to the test day instructions at the bottom right corner. Now, there's another way to get to the middle. You can work from the ends into the middle, like so. So on the ends, we have shrew and horse. They're gone. Then we have cactus mouse, and that's gone along with human. And then we get rid of flying squirrel and dog, leaving us again at the middle of rabbit. Again, that's the answer. So just make sure that if median pops up, you know, okay, it's the middle. What is the middle? Making sure you're going in order to find it. Next question for this information that we talked about with metabolism. Take a few moments, pause the video, read through this, and when you're ready, restart it. All right, so now that we have this, let's be very careful with what's going on. Note it mentions without the shrew here. Then we're dealing with the new average metabolic rate. So we're taking the shrew out. And here's our shrew right there in our graph. Now, how does the shrew's metabolic rate compare to the other animals' metabolic rates? So make sure that you check the y-axis, which means that you should check how much higher or lower the point for the shrew is as compared to the other points. So is the shrew's point higher, lower, or about the same? Well, it's higher. It's the highest up, right? So if we remove the shrew's metabolic rate, what would happen to the average metabolic rate for the rest of the points? In other words, by removing the highest rate, will the new average go up, go down, or stay about the same? Well, you get rid of the highest here, so that metabolic rate would have to go down. There we go, and that lowers the overall average. And that matches answer choice B. Yeah. One more question for this metabolism information. Here it is. Pause the video to get acquainted, and when you're ready, restart it, and we'll work through. Okay. Now, we need to predict, here's our prediction thing, about the elephants. What will be true of them based on the graph. And note what they tell us about the elephants. Yes, they weigh more than adult horses. So let's think about this when it comes to our graph. As the animals get heavier, what happens to their metabolic rates? So getting heavier, here's the body weight going across. Of course, metabolic rate, we match here with the y-axis. Now, what that means is this. If we're dealing with the horse's weight, it would go right here, this point, on the x-axis. If you were dealing, let's just say the shrew, you're dealing with that metabolic rate, which we saw before, it would match a point on the y-axis there. Just be careful with how you translate that. Okay, so taking a look, again, as the animals get heavier, what happens to their metabolic rates? Well, it goes down. So body mass goes up, metabolic rate goes down. We can see that trend here. So if elephants weigh more than adult horses, that's what they tell us right at the beginning here of this question. So if that's the case, would the elephant's rate be higher or lower than the horse's rate? Again, the elephant weighs more. Well, according to what we said, the elephant would have to, since it weighs more, have a lower metabolic rate than the horse. This means that C is correct. Yeah. Now, up next is the data for the next two questions. Let's go through this information, similar to how you went through the metabolism